I welcome you to my channel. Let's delve into computer software today. Programs and instructions that tell the computer how to perform specific tasks are called computer software. Here are the different types of computer software. Operating system or OS. An operating system is software that manages computer hardware, software resources, and provides various services for computer programs. Here are key aspects of operating systems. User interface or UI. Operating systems offer user interfaces for interaction. Graphical user interfaces or GUIs, like those in Windows and macOS, use visual elements like icons and windows. Command line interfaces or CLIs, as in Linux, allow users to interact with the system through text commands. Kernel. The kernel is the core of the operating system, managing hardware resources and providing essential services. It handles tasks such as process management, memory management, and device communication. File system. OS organizes data on storage devices through a file system. It manages files, directories, and file access permissions. Device drivers. These are specialized programs that enable communication between the operating system and hardware devices. Drivers facilitate the use of peripherals like printers, graphic cards, and network adapters. Process management. The OS oversees processes, which are instances of executing programs. It manages processes creation, scheduling, and termination, ensuring efficient utilization of the CPU. Memory management. OS allocates and deallocates memory to programs and processes. It ensures that each program has the necessary memory space and prevents unauthorized access. Security and access control. Operating systems implement security measures, including user authentication, encryption, and access controls to protect data and prevent unauthorized system access. Networking. OS provides networking capabilities, enabling communication between computers. It manages protocols such as TCP over IP and facilitates internet connectivity. Utilities and services. Operating systems include utilities and services for system maintenance and optimization. Examples include backup tools, antivirus programs, and system monitoring services. Updates and patches. OS vendors regularly release updates and patches to enhance security, fix bugs, and introduce new features. Users are encouraged to keep their operating systems up to date. Major operating systems include Microsoft Windows, Mac OS, Linux distributions like Ubuntu, and Unix variants. Each has its strengths, and the choice depends on factors such as user preferences, software compatibility, and intended use. Device drivers. Device drivers are software components that enable communication between the OS and hardware devices connected to a computer. These drivers act as intermediaries, translating high-level OS commands to instructions that the hardware can understand and execute. Here are key aspects of device drivers. Purpose. Device drivers serve as a bridge between the OS and specific hardware components, allowing them to work together seamlessly. Example, graphics drivers enable the OS to communicate with the graphics card, ensuring proper display functionality. Functionality. Device drivers provide a standardized interface for OS to interact with hardware, abstracting the intricate details of hardware communication. Example, printer drivers enable the OS to send print jobs to a printer by converting the print command into a format the printer understands. Types. Different types of device drivers exist, including those for peripherals such as printers, scanners, system components such as graphic cards, network adapters, and storage devices such as hard drives, SSDs. Example, USB drivers facilitate communication with USB connected devices. Installation. Drivers are typically installed during the setup of an OS or when connecting to a new hardware device. They can also be updated to fix bugs, enhance performance, or add new features. Example, when you connect a new webcam to your computer, the system may automatically install the necessary device drivers. Compatibility. Device drivers must be compatible with both the OS and the specific hardware they are intended for. Example, Windows drivers may differ from those designed for Mac OS or Linux. Updates. Manufacturers release driver updates to address compatibility compatibility issues, improve performance, and introduce support for new features. Example, graphics card manufacturers provide regular driver updates to optimize performance for newly released games. User interaction. Users may interact with device drivers through device management interfaces to troubleshoot issues, update drivers, or configure device settings. Example, in the Windows Device Manager, users can view, update, and uninstall device drivers. Stability and reliability. Well-designed and up-to-date device drivers contribute to the stability and reliability of the overall system by ensuring proper communication between the OS and hardware. Example, stability improvements in a Wi-Fi driver may prevent connection drops or connectivity issues. Device drivers are essential for the proper functioning of hardware components within a computer system, ensuring seamless communication and interoperability between software and hardware. Application software. Application software, commonly referred to as apps or programs, is a type of software designed to perform specific tasks or functions for end users. Unlike system software such as OS and device drivers, application software is meant to address the diverse needs and preferences of users. Here are key aspects of application software. Purpose. Application software serves specific purposes or tasks ranging from productivity and creativity to entertainment and communication. Example, word processors such as Microsoft Word, Google Docs, image editors such as Adobe Photoshop, and video players such as VLC Media Player. Categories. Applications fall into various categories, including productivity tools, multimedia applications, communication software, and entertainment programs. For example, spreadsheet software such as Microsoft Excel, Google Sheets falls under productivity, while music streaming apps such as Spotify, Apple Music belong to entertainment. User interface. Application software provides a user interface through which users interact with a program to accomplish tasks. Example, the graphical user interface of a web browser such as Google Chrome, Mozilla Firefox allows users to navigate the internet. Customization. Users can often customize settings and preferences within application software to suit their needs and preferences. Example, web browsers allow users to customize their homepage, install extensions, and manage privacy settings. Development. Applications are developed using programming languages and frameworks tailored to the specific needs of the software. Example, mobile apps may be developed using languages like Java for Android or Swift for iOS. Installation. Users typically install application software on devices through installation files, app stores, or online downloads. Example, installing a new antivirus program or a video editing application on a computer. Updates. Developers release updates to fix bugs, enhance features, and improve security in application software. Example, updating a messaging app on a smartphone to access new features and security improvements. Examples of application software. For productivity, Microsoft Office Suite, which includes Word, Excel, PowerPoint, Slack. Creativity, Adobe Creative Cloud for Photoshop, Illustrator, Premiere Pro, GarageBand. Communication, email clients such as Outlook, Gmail. Messaging apps such as WhatsApp, Telegram. Entertainment, video players such as VLC Media Player. Music streaming, Spotify, Apple Music. Video games. Application software plays a crucial role in enhancing user experiences and meeting various computing needs, making it an integral part of everyday digital interactions. Antivirus software. Antivirus software is a type of application software designed to detect, prevent, and remove malicious software, commonly known as malware, from a computer or network. Here are the key aspects of antivirus software. Purpose. Antivirus software aims to protect computers and devices from various types of malware, including viruses, worms, Trojan horses, spyware, adware, and ransomware. Real-time protection. Many antivirus programs offer real-time protection, actively monitoring files, programs, and network activity to identify and block potential threats in real time. Example, when a user downloads a file, the antivirus software scans it immediately to check for malware before before allowing access. Scanning. Antivirus software performs regular scans of the system, including the entire hard drive, specific files, and incoming data to detect and eliminate malware. Example, scheduled system scans during periods of low computer usage to ensure comprehensive protection. Quarantine. When potential threats are detected, antivirus software may quarantine or isolate infected files to prevent them from causing harm, while giving users the option to review or remove them. Example, placing a suspicious file in a separate quarantine folder to prevent it from executing. Signature-based detection. Antivirus programs use a signature database containing known patterns of malware to identify and eradicate threats. Example, identifying a virus by recognizing specific patterns or signatures in its code. Heuristic-based detection. Antivirus software may use heuristic analysis to identify previously unknown malware based on behavioral patterns rather than known signatures. Example, detecting suspicious behavior in a program that resembles the characteristics of ransomware. Automatic updates. Antivirus programs regularly update their virus databases and software to stay current with the latest threats and security measures. Example, automatically downloading and installing the latest virus definitions to ensure protection against new malware variants. Firewall integration. Some antivirus solutions include firewall component to monitor and control incoming and outgoing network traffic, adding an extra layer of security. Example, blocking unauthorized access attempts from external networks. Email scanning. Antivirus software may scan incoming and outgoing emails for malicious attachments or links to prevent the spread of malware via email. Example, detecting and removing a virus attached to an email before the user opens it. User interface. Antivirus software typically provides a user-friendly interface where users can view security status, initiate scans, and manage settings. Example, a dashboard displaying real-time protection status, recent scan results, and options for customization. Antivirus software is an essential tool for maintaining the security and integrity of computer systems by preventing and addressing potential threats posed by malicious software. Programming languages. Programming languages are formal systems designed to instruct computers and perform specific tasks through a set of predefined instructions. These languages act as an intermediary between human programmers and the machine, allowing developers to write code in a syntax that is readable and understandable to them. Here are the key aspects of programming languages. Syntax. Programming languages have a specific syntax, which is a set of rules governing the structure and combination of symbols, keywords, and expressions used to write code. For example, in Python, indentation is used to define code blocks, while in C, curly braces are employed. High-level versus low-level. High-level languages are designed to be more user-friendly and abstracted from machine details, while low-level languages provide more direct control over hardware. For example, Python and Java are high-level languages, while assembly and machine code are low-level. Compiled versus interpreted. Compiled languages are translated into machine code before execution, whereas interpreted languages are executed directly by an interpreter at runtime. For example, C and C++ are compiled languages, while Python and JavaScript are interpreted. Object-oriented versus procedural. Object-oriented languages organize code around objects and classes, while procedural languages focus on procedures and routines. For example, Java and C# are object-oriented, while C and Pascal are procedural. Popular programming languages. There is a wide variety of programming languages, each serving specific purposes. Popular languages include Python, JavaScript, Java, C++, C#, and Ruby. For example, Python is widely used for web development and data science, while JavaScript is commonly employed for building dynamic web pages. Domain-specific languages. Some languages are designed for specific application domains, such as SQL for database queries or MATLAB for mathematical modeling. For example, HTML and CSS are domain-specific languages for web development. Syntax paradigms. Programming languages support different programming paradigms, including imperative, functional, and declarative. For example, C is primarily imperative, Pascal is functional, and SQL is declarative. Frameworks and libraries. Many programming languages have associated frameworks and libraries that provide pre-written code and tools to simplify and expedite development. For example, Django is a web web framework for Python, and React is a JavaScript library for building user interfaces. Learning curve. Different languages vary in complexity, making some more accessible for beginners, while others offer advanced features for experienced developers. For example, Scratch is a beginner-friendly language, while languages like Rust may have a steeper learning curve. Community and ecosystem. Programming languages often have vibrant communities and ecosystems with resources, forums, and libraries that support developers using those languages. For example, Python community is known for its extensive ecosystem of libraries and supportive forums. Programming languages are versatile tools that enable developers to create a wide range of software applications, from simple scripts to complex, large-scale systems. The choice of a programming language depends on factors like the intended application, developer preferences, and project requirements. Utilities. Utilities refer to software tools or programs designed to perform specific tasks that enhance the functionality, efficiency, or maintenance of a computer system. These tools are often built into operating systems or installed separately to aid users in managing and optimizing their system. Here are the key aspects of utilities. System maintenance. Utilities help maintain the health and performance of a computer system by performing tasks like disk cleanup, defragmentation, and system optimization. For example, Windows uses disk cleanup, macOS uses disk utility, and cross-platform for BleachBit. Security. Security utilities focus on protecting the system from threats, including antivirus programs, firewalls, and malware removal tools. For example, Windows Defender for Windows, Sophos for cross-platform, and Clam XAV for Mac OS. Backup and recovery. Utilities for creating backups and recovering data in case of system failure or accidental loss. For example, Mac OS Time Machine, Windows File History, and cross-platform uses rsync. File management. Utilities assist in organizing, copying, moving, and manipulating files and directories. For example, File Explorer for Windows, Finder for Mac OS, and Nautilus for Linux. Network tools. Utilities for managing and troubleshooting network-related tasks, including ping, traceroute, and network analyzers. For example, Command Prompt for Windows, Terminal for Mac OS and Linux, and Wireshark for cross-platforms. System monitoring. Tools that provide real-time information about system performance, resource usage, and hardware health. Task Manager for Windows, Activity Monitor for Mac OS, and HTOP for Linux. Text editors. Simple text editors used for creating and editing text files, scripts, and configuration files. For example, Notepad for Windows, TextEdit for Mac OS, and Nano for Linux. Compression and decompression. Utilities for compressing files into archive formats and extracting compressed files. For example, WinZip for Windows, Archive utility for Mac OS, and tar for Linux. Disk management. Tools for partitioning, formatting, and managing storage devices. For example, disk management for Windows, disk utility for Mac OS, and gparted for Linux. Task automation. Utilities that enable users to automate repetitive tasks or schedule processes. For example, Task Scheduler for Windows, Automator for Mac OS, and cron for Linux. Utilities play a crucial role in ensuring the smooth operation, security, and efficiency of computer systems. They offer users the means to troubleshoot issues, manage resources, and customize their computing experience. Depending on the operating system, users may find a variety of built-in utilities or choose from third-party options to meet their specific needs. Understanding the interplay between hardware and software is crucial for effective computing. Hardware provides the physical foundation, while software gives instructions on how to utilize and interact with that hardware.